capability as well as performance indices. So currently I have been working in a chemical manufacturing industry. So I have taken it for a pharmaceutical product. And first of all, I'd like to provide a brief about a pharmaceutical industry, like how it is going to work and what is the linking between uh, the product manufacturing as well as the type of statistical analysis that we are going to use. So basically, pharmaceutical industry is responsible for manufacturing of drugs or medicines, and it is going to be for the benefit of human beings and sometimes for the animals. So we are going to manufacture the drugs in two steps. The first thing is bulk manufacturing, and the second one is the formulations, like whatever the bulk drugs are being manufactured, so that are being encapsulated in formulations, like depending upon the dosage that is required by humans as well as the animals. So they are going to formulate it. And if we are able to see, there will be certain similarities between the pharmaceutical manufacturing as well as the domestic cooking. Like whatever the chemicals that usually will be using can be compared to the vegetables. And also, if you compare the solvents, like we'll be having different type of organic solvents. And if you want to compare it, so we can compare with the oil as well as the water that we'll be using for cooking, and also the catalyst that we'll be using to enhance the rate of reaction. So that can be compared to the spices or the salt or the chili powders, which will be used to enhance the taste. And finally, what are the cooking utensils are there, so that we can compare with the equipments that we'll be using for manufacturing. And the next step is about the quality. So as we are going to manufacture the drugs for the welfare of humans, so the quality is going to be a major role. Like quality is going to play a major role. Am I audible, sir? So sorry, I forgot to ask.
Yes, yes, Ajay, you are audible.
Yeah,
Please
okay,
proceed.
fine. So for each and every product that is being manufactured, so it will be having its own specification, and this specification is going to be defined depending upon the customer requirement, like what exactly customer wants. So we are going to gather the information, and depending on that, we are going to prepare the specification. And once after taking the concurrence from customers, so we are going to go with the manufacturing. And depending on that, we are going to develop a particular manufacturing process. So ideally, the voice of process, like what exactly the process is going to deliver, it should be a subset of the customer requirement. So if it is going to be the same, or if it is going to comply with that rule, we can say the process is stable. And also what we'll be doing is, sometimes as the process is going on, so intermittently we are going to check the quality, like whether it is within the specified range or not. And sometimes after complete manufacturing, we are going to take sample and then we are going to analyze it. And sometimes what we'll be doing is, after completion of 100 or 150 batches, like for example, quarterly or half yearly, we'll be collecting all the data. And then we are going to identify whether the process is in control or any failures have been occurring. So this and all we are going to verify it periodically. And if it is a case of a new development, so we'll be going using the tools like DOE, like the statistical tools like DOE to optimize the process parameters. So coming to the type of statistical analysis which we'll be using in pharmaceutical industry, like the first thing is the DOE. As a part of development, we'll be using this tool to optimize the process parameters like temperature, pressure, and also sometimes the reactant concentration, etc. And the next thing is the process capability analysis. Like whenever we are going to perform any periodic review of data, in such a case, we'll be using this process capability analysis to check the consistency. And the next one is the hypothesis testing. So during the periodic review, or sometimes during the course of any failure or any abnormal event, if something goes wrong, what immediately we'll be doing is we'll be launching an investigation. So as a part of investigation, sometimes if we don't have adequate data to prove the hypothesis, so then we'll be going with these testings, like by considering all the data, and then we are going to see whether the hypothesis is right or not. And depending on that, we are going to prove the investigation. And the next thing is the multiple regression analysis. So sometimes we'll be having multiple variables which are going to have some impact on the output. In such a case, we are really using this multiple regression analysis to identify what type of correlation or what type of impact is having. And the next thing is the measurement system analysis. So whenever you are going to transfer the analytical methods to the plant scale, from the development side. So in such a case, we are going to check the repeatability and reproducibility. In such a case, so we'll be using this measurement system analysis. And the next one is, sir, some noise is coming. Okay. Mm, okay. So as a part of this like as part of investigations, we'll be using this scatter plots. Similarly, like what we have mentioned in this multiple regression analysis, to identify what type of relationship the variables or the response is having, we will be using the scatter plot as a part of root cause analysis. And finally, we'll be using the Pareto analysis. Like during the course of periodic review, if we have multiple failures, so in order to prioritize the failures and the investigation, we'll be identifying certain cases or certain areas where we need to focus the most. In such a case, we'll be using this 80/20 rule. And coming to softwares which we'll be using for statistical analysis are, the first one is Minitab. This is going to be like most extensively we'll be using this. And the next one is the Design Expert, which we'll be using for DOE sometimes. So now coming to the topic. So whenever we want to understand whether the process is performing good or bad, we'll be performing the capability analysis. So the first thing is capability. We need to understand what is capability and what is capability analysis. So capability is something like the ability which is required to perform a specific task, and that too with precision we have to do. So capability will make us to understand what is the ability. And capability analysis is something like it's a systematic procedure to understand what is the capability. So in order to measure the capability analysis, we will be using certain metrics like CP/CPK as well as PP/PPK. Now the question is going to be like, what are these indices? So how to interpret and what does exactly they represent? So when to use these indices and what type of action plans or something what we can do depending upon these indices. So first of all, CP/CPK is going to be of one family and PP/PPK is going to be the other family. But they are going to have some close correlation or some close similarity is going to be there. So CP/CPK are nothing but the capability indices. So C represents capability, while coming to this PP/PPK, this capital P, we can say it represents the performance. So coming to this CP as well as CPK. CP will help us to refer this capability index, and CPK will help us to understand the centering capability index. So how well the data is centered. Similar is the case of PP and PPK. One represents the performance index and second represents the performance centering index. So if you are able to see the graph, usually which will be using, which will be interpreting during the course of capability analysis. So it represents two things. The first thing is the specification limits. Usually we'll be mentioning this as the voice of customer. And at the center or at somewhere on the graph, we'll be finding a curve. And this curve is going to represent the process voice, like how the process is performing and how the data points are lying. So after saying this, the next thing is going to be like, what is the difference between capability and performance? Why? Because here CP/CPK represents about the capability and PP/PPK represents the performance. So we should understand the major difference between capability and performance. So coming to that, so if you are able to see, we need to check two things. One is the past as well as the future. So capability means usually how we can define, like capability means we are going to say the ability, like we are going to say, but we are going to say about the future, like it can perform or it is capable. That means we are going to say about the future while coming to the performance. So performance is going to be established depending upon the existing data, how it has performed. That means in the previous stage, how it has performed. So depending on that, we will be interpreting the performance. So in such a case, if you want to mention something about the capability, then we'll be using CP/CPK. So this refers to the future thing, like depending upon the existing data. While coming to the past, like we'll know what we have done. So performance will help us to understand that. And the indices that we'll be using is PP/PPK. So after understanding about the difference between capability as well as performance, so we should understand what is exactly they infer with certain examples. Like to make you understand better, I have taken one example here. So as previously mentioned, CP-CPK is going to be one family and PP-PPK is going to be from second family. But within these, there will be certain similarities, like the CP as well as PP is going to be referring something specific, and those are going to be similar. So CP or PP will help us to understand how the data points can fit within the specification limits. Like if we found or if we find certain requirement from a customer and how the process is performing, whether all the data points are lying within the range or not, how the data points are fitting within the specification limits, that we can understand from CP as well as PP. And coming to CPK or PPK, this will help us to understand whether the data is centered or not. So here we got an example. So let's take the case. So let's take the case of a product yield, and the data is gathered from 50 batches, and the specification limits from the yield is 95 plus or minus 25 kg. So this is the specification limit. So that means the lower specification limit is going to be 95 minus 25, that is 70. And the upper specification limit is going to be 95 plus 25, that is 120. So the given range is 70 to 120. So from this, we can say this CP or PP will help us to understand how many data points are fitting within 70 to 120. Whereas CPK or PPK will help us to understand whether all the data points are centered. That is, the centered value is 95. So if all the if majority of the data points are lying near to 95, that is the standard, so automatically the CPK or PPK is going to be increased. So this is the difference between these two. And the next thing is when to use these indices and how to estimate these indices. So here we got one more example so that we can understand this better. So if you are able to see the first case, here we got one car which need to be fitted into a area. And if you are able to see here, the car width is going to be the voice of process. Why? Because parking a car is going to be the process, and I can consider the car width as a voice of process. And similarly, we got a garage here, and this garage got certain width. So ideally, if my car width is going to be less than that of the garage width, easily it can fit into. So if it is going to be same, like both are going to be same, then CP equals to 1 as well as CPK equals to 1. Let's come to the second case. If my car width exactly fits at the center of the carriage, so I can say the CP equals to 2 as well as CPK equals to 2. But if in case my car is going to be parked or it got skewed towards any of the sides, so here it is being shown as a, just a minute. So here it is being shown as it got skewed towards the right side. That means, so the car is not going to be fitted. Why? Because the direction that I have selected is towards the right side, and also the car is not going to be fitted completely. Since the car is not going to be fit into the garage, at the same time, the CPK, that means the car is not centered. So both the values were reduced, less than 1. And coming to the fourth case, so the car is going to be completely fitted into the garage, but it is not at the center place. So CP is high, the CPK is low. Why? Because here the car is not fitted into the center. The similar thing is going to be explained here using these graphs. Okay, so coming back to the point, when to use and how to use these indices. So here we have to use the CP-CPK when you have a sample data. That means if you got multiple observations, multiple in the sense, if you take a pharmaceutical manufacturing, we are going to manufacture same type of product from multiple years. In such a case, the number of batches that we have taken till date is going to be very huge. In such a case, we will be not able to collect all the batches data. But we can distinguish between the type of data, I mean, the amount of data that we have collected. Depending on the amount of data that we have collected, we can distinguish what to select. Either it's a CPCPK or PPPPK. So usually if you got sample data, we'll be going with a CPCPK. So if you got less than 100 data points or observations, you can take this CPCPK. And coming to PPPPK, you have to use this when you have a population data. That means if your number of observations are greater than or equal to 100, you can prefer these two things. So the next thing is how to estimate. So ideally, we'll be using some hand calculations. Like previously, we used to have some hand calculations, and depending on that, we will be hand as well as Excel. So depending on that, we'll be estimating these two. And currently, we can use Minitab to do these things. So coming to estimation, so CP or PP refers to the upper specification limit minus lower specification limit by 6s. In case of CP, this is going to be the sample standard deviation. And coming to the case of PP, it is going to be the population standard deviation. And the next thing is CPK as well as PPK. So these two are going to be something similar, like the calculation method that we'll be using. So coming to CP, it is going to be the minimum of CPU and CPL. So CPU is the upper specification limit minus the sample mean divided by 3 times to the standard deviation of sample, where CPL is the sample mean minus the lower specification limit divided by 3 times to the standard deviation. Similar is the case of PPK. Like here you will be having the population mean as well as the population standard deviation. And the next thing is like the next thing that we want to understand is the relationship between the sigma level as well as the CPK or PPK. So the relation between the sigma level as well as the CPK or PPK is that sigma level is equals to 3 times to the CPK. If your CPK value is 1, the process capability is 3 sigma. If your CPK or PPK value is 1.33, the process capability is 4 sigma. If it is 1.67, process capability is 5 sigma. And if it's a 2, then the process capability is 6 sigma. So to understand the thing better, so here we got the graphs for 3 sigma, 4 sigma, 5 sigma, and 6 sigma. So here if we are able to compare all these four, coming to the case of 3 sigma. So here the data spread is more than that of the specification limit. And whatever the data spread that is absorbed beyond this upper specification limit and the lower specification limit, we can say these data points are nothing but the outliers or the rejected pieces. So in the case of 3 sigma, so there are many outliers or the rejections, and also the centering is it's not that great. While coming to the case of 4 sigma, so the rejections were reduced, and also the centering is better when compared to 3 sigma. And coming to this 5 sigma, here is the same case. The rejections are very low and there are no rejections to say. And also the centering has been improved. While coming to this 6 sigma, so forget about rejections, but also the centering is very high. So we can say this can be as a world-class process. Why? Because the amount of standard deviation which is available in the process is very low when compared to other levels. So the next thing is about the analyzing the process capability using Minitab. So whenever we want to analyze the process capability using Minitab, we got few steps here. First thing is we should collect the data and enter the data in Minitab worksheet. And then we have to plot a control chart from the collected data. And from that, we need to identify the outliers and then we need to investigate those outliers. Why? Because outliers means so they are a result of certain special cause variations. In such a case, we should understand what has impacted them. And after performing some detailed investigations, so we have to provide some action plans and then we need to eliminate them. And then we have to repeat the same till the data set is free from outliers. So once it is done, we need to check the data distribution type, whether it's a normal or non-normal. So depending on this data distribution type, we are going to perform the capability analysis. So in order to make you understand better, I have taken a case study, which I have done previously. So here the thing is we need to analyze the process capability for a pharmaceutical product. So the case is that a same product is being manufactured in two different sites of a same company. So due to higher inflow of other products, like whenever you're going to manufacture same type of product at two different sites, that means multiple equipments are getting engaged. So in order to reduce the equipment usage and also in order to accommodate the inflow of new products, so what they have done is like what the company has proposed is, so we need to control the production and also we need to relieve some of the equipments. So as a part of that, so we need to analyze the capability of these uh, capability of manufacturing at two different sites. And depending on that, we have to take a call where we need to stop the manufacturing. Why? Because if you are going to stop the manufacturing at least in one of the site, so maybe we can execute two other products. So for the same to evaluate, we have taken total 83 batches data from two different sites. So before going into the usage of Minitab, so is there any questions to take? So if anyone has questions, then I'll try to clear those and I can proceed further. If no questions, then directly I'll jump into usage of Minitab. Okay. Since no questions, so I'll be taking the case. So here is the case. The yield data that we have collected from two different sites, and the desired yield range is mentioned as 600 plus or minus 2 kg. So we need to perform the process capability and then we need to interpret the results. So first of all, I'll be taking the the yields of two different sites, and then I'll try to perform capability analysis one by one, and then we can compare. So this is going to be the worksheet where we'll be giving the input, and above you'll be finding the sessions window where Minitab is going to deliver the output. So just copy and paste. So as per the procedure that was mentioned, first of all, we need to perform or we need to plot the control charts. So before plotting the control chart, we should understand like there will be multiple types of control charts. So depending on the data that is available, so we need to identify the control charts. So here we got some continuous data. Why? Because the data that we have collected is going to be measurable. So this is a continuous data. So as we are going to have or we are going to interpret the continuous data, we have to take the IMR chart. And also one thing that we need to remember is here the subgroup size is 1. Why? Because we have collected one data point from one batch. So get into stat and into this control charts and in this variable chart for individuals. Then we have this IMR. Click on it. So here it will be asking about the variables. First of all, I'll take the case of plant 1. So double click on it and then click on OK. So Minitab has plotted the control chart for plant 1. So from this, we need to identify the outliers. So Minitab is going to give some different representation for these outliers. So whatever the dots that are mentioned in red color shall be considered as outliers. So in this individual chart, we have two outliers. And in this moving range chart, we have one more outlier. So what is the difference between individual and the moving range chart? So this also we have to understand. So individual chart means, so here, whatever the values that we have taken are going to be interpreted. I mean, they will be plotted individually. But while coming to moving range, so this will be able to, this will help us to understand what is the difference between two different data points. So how the data is moving. So if you are able to see here, the individual value is 599.3 and the next individual data point is 598.9. So the difference is 0.4. So the first value is going to be 0.4 in the moving range chart. Similarly, all other data points will be gathered. So total, the test has failed at 13, 46, and 60. So what we have to do is we need to investigate these data points and then we need to eliminate from the data set. So as of now, what I'll be doing is simply I'll be eliminating these data points. So I'll be coming from the bottom. So since I want to eliminate this data point number 60, I'll be cutting the below data points and then I'll paste it over. And the next step is 46. So simple cut and paste over 46. And then we have data point number 13. So cut from 14 and paste on it. So once it is done, you can either plot the next IMR control chart from getting into stat, or else you can update these results here. So I'll be updating it. So now if you're able to see the same control chart, there are no outliers. So the data is free from outliers. And now what we have to do is we have to check the normality of this data. So for checking the normality, get into stat and then the basic statistics. And this you will be having the normality test. So here I need to check about the plant one. So click on it and click on OK. So from this probability plot, here we got the summary, like the average, the standard deviation, and the number of data points, and the Anderson-Darling coefficient, and also the p-value. So we need to check this probability value, and as Minitab is going to do the analysis with 95% confidence, the remaining 5% is going to be some variations. So ideally, this p-value should be greater than that of the 5%. So 5% represents 0.05. Since here the p-value is greater than 0.05, we can say the data is normal. Okay, so click on OK. Since the data is normal, we can go with directly the capability analysis. For doing the capability analysis, get into stat and then the quality tools and then the capability analysis. In this, you can select normal. So I'll be selecting this plant one and the subgroup size is 1. So here the lower spec that is mentioned is 598. Why? Because so here the yield range is mentioned as 600 plus or minus 2. So the lower specification limit is 598 and the upper specification limit is 602. So taking the same, click on OK. And now let's see the process capability report of plant 1. So here the values are mentioned as CP is 1.4, CPK is 0.81. So I'll try to make a note of these things. CP, CPK, PP, PPK. Here is for plant 1 and here it is for plant 2. So for the first case, it is 1.4 and 0.81. And for PP, PPK, it is 1.23 and 0.71. Okay. And let's come to the case 2. So again, we need to plot the control charts. We need to identify the outliers, then check the normality, and then capability analysis. Get into stat, variable charts for individuals, select IMR, and now click on plant 2. Click on OK. So now Minitab is going to show us the outliers. So outliers are available at data point number 19, 30, 41. So we need to investigate and then we need to eliminate them. So I'll be coming from bottom. Select, cut, paste. And the next data point is 30. Cut, paste. And the next data point is 19. Cut and paste. And now just click on update these results. So after updating, again, 2 more outliers are there. So these outliers are resulted due to the high variability. So it's again the observation number 41 and 19. So again, investigate and eliminate 19 and 41. So again, click on update these results. So we got finally one outlier. It is a data point number 54. Click on OK. Identify this 54 number data point. Investigate, eliminate, update. So I think these outliers 27, 38, and 39. 37, 38, and 39. Update it. Oh my God. So finally, two more data points. Outliers are there at 37 and 38. So here, the moving range itself is very high. So maybe this is one of the reason. 37 and 38. Combinedly, we have to take out. So finally, the data set is free from outliers. So click on OK and then check the normality. Get into stat, basic statistics, normality test, and then select plant 2. So now if you are able to see the p-value is greater than 0.05, it is greater than 0.6. So that means we can say the data set is normal. And then to analyze the capability, get into stat, the quality tools, capability analysis, and the normal data. Now do it for plant 2. Click on OK. So here if you are able to see, almost all the indices are less than 1. Anyhow, let's first record them in an Excel sheet. CP is 0.95 and CPK is 0.93. And PP is 0.84, PPK is 0.82. So the number of data points that we have selected here is 83. That means it is less than 100. Since the data set that we have collected is only a sample, and also it is less than 100. So I have to rely on CP and CPK. Okay, so depending on this, I have to check the capability. And here, if you're able to see, the CP is 1.4 for plant 1, and for plant 2, it is 0.95. That means in the case of plant 1, majority of the data points are falling within the specification limits. That means the data spread is less than that of a customer specification. So that means the process is capable, we can say from this. And coming to the plant 2. So here it's almost equals to 1, but it is less than 1. That means we can say the process is not capable, depending on CP. And also coming to centering. So here, if you are able to see, the centering is less in the case of plant 1, but it is high in the case of plant 2. But now what we have to do? If you are able to see, like, depending on the data, what we can say is from CP, the process is capable for plant 1. For plant 2, it is not that capable. But about the centering, for plant 2, the data shows much more centered when compared to plant 1. Now then we can revisit the site, but anyhow, we are going to select plant 1. But to improve the centering, what we can do is as a part of short-term action plan. So we can revise the yield limits, like whatever the specification limit that is given. So this can be revised. Why? Because if you are going to revise, automatically the centering will increase. First of all, let's see how the data is skewed. So this is for plant 1. And here, if you are able to see, the data was completely skewed towards the left-hand side. So that means the the median has been shifted towards the lower specification limit. To improve that, so maybe like we can revise the yield limit from 598 to 602 to 597 to 601. Let's check the capability after revising it. So get into stat, quality tools, capability analysis, normal, and here select plant 1 and revise these limits. Why? Because the process is capable, but only thing is the centering is missed. So if you are going to change the specification limits, maybe the centering can get better. So I have reduced by 1 kg on both sides. Click on OK. Well, now see. So the CP remains same, but the CPK value has increased. Previously it is 0.81, now it is 1.29. That means I have selected site 1. I have selected to continue manufacturing in plant 1, but as a part of short-term action plan, I want to improve the centering. So to improve the centering, only thing that I have done is, so previously the limit is 598 to 602. And then what I have done is, I have shifted it to 597 to 601. So now the revised capability is 1.29. So what I'll be insisting to management is that better to go with the plant 1 and better to stop manufacturing in plant 2 so that we can accommodate some other products. So this is the inference that I'll be giving to the plant and I have given previously. So this is how we need to evaluate the process capability in Minitab using these indices. So if you have any questions in that, so you can ask. So Anand sir, Arun sir, like first of all, I'll be going with teammates.
Uh, you're you're completed? Or
Yeah,
still?
yeah, we have done. Yeah, I am done.
Okay, okay. So, well, good. Only one question.
Uh-huh. Go on.
What is the difference between CP and PP and CPK and PPK?
Yeah,
In
that's
simple
what.
way, how we can understand?
So one represents the capability, the second represents the performance. So CP represents the capability, like we'll be using to express the capability, and whereas PP it's performance. And also we got a major distinguishment, like when we can use these two things. That is depending upon the sample data as well as population data.
But somewhere I read that one is short-term capability, one is called long-term capability.
Yeah, CP-CPK is going to be the short-term capability, whereas PP-PPK is going to be the long-term capability. Why? Because the reason why we are going to mention that is, so CP and CPK, these two are going to be interpreted depending upon the sample data. So that means this is the short-term capability. Whereas coming to the PP-PPK, so this is going to be depending on population data. So this is going to be more accurate.
But both are capability, na? CP, CPK,
So one is
PP.
capability, the second is performance. Like see, I'll explain you. Okay then, I'll take one case to make you understand better. So do you remember recently certain indices has been, certain index has been released. I don't know who has released, but it is from the Western side, and the index represents the hunger index as well as the happiness index. So do you remember that, sir?
Uh,
Like hunger index and happiness index. So they have made a list up to 130 countries, I think. So India was lagging when compared to Pakistan as well as Sri Lanka.
yes, 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 yes. Something.
Huh.
Uh,
But coming to practical case, so it is not that severe in India when compared to Pakistan as well as Sri Lanka. Why? Because Sri Lanka it went almost bankrupt, and Pakistan, so they are fighting for food, and also whatever the prices are there for the consumables, so they have skyrocketed. But in India, it is okay. I'm not saying it is better, but it is fine when compared to them.
Yes, yes, yes.
So immediately, our government has given some statement mentioning that. So it can be like a like whatever the data that they have collected to analyze the capability. So it is depending upon only the short sample data. I mean, the sample size is very less. So India is having a population of 140 billion, and they have collected a sample size of 3000. See, here also I got one thing, the presentation. See this. So this is a population and this is a sample. So whenever I want to take out a sample from population, so there can be different strategies, but ideally we'll be going with random sampling. So randomly I can select. So there can be certain like due to picking up this sample from different areas randomly, so there can be certain bias. So maybe it could be leading us to different results. Similar is the case of CPCPK and PPPPK. Whatever the results that you are going to get from CPCPK are not going to be that accurate. Why? Because you are going to collect only the sample. So we are going to say it as a short-term capability. But while coming to this PPPPK, so you are going to analyze the total population, or else you will be picking up the maximum sample size. Maybe from that you can get some accurate results. So this will be mentioning as the long term. Is it clear, sir?
Yeah, yeah. But see, when we increase the data, then definitely it will give more better result than the less data.
Yeah, that's what. So if you are going to analyze
Oh,
population, you
okay.
will be getting accurate results. But if you are going to analyze a sample, so we don't know. Maybe there can be certain abnormalities in sampling. Again, we need to further investigate. Like if it is not going to match the practical case, so we have to investigate. So in case of that, like instead of going with this, if you have a complete data, so go with a PPPPK. But only thing is data collection is going to be something difficult.
Okay. Thank you.
Yeah. Yeah. Okay, sir. Thanks. So any other questions from other participants? Anurag sir, Hemant sir, and Jyoti Prasad sir, I forgot you.
No question from my side. I'm good.
Yeah. Okay, thanks sir. Mm, Anand sir, Anurag sir, and Hemant.
Nothing from my side also. Right.
Yeah, okay sir. Okay, thanks. So Anurag sir and Hemant sir, you both were had to comment on this. So if
Yeah, I
anything
think
went
this
wrong,
was quite clear.
sir.
Yeah, so this was good.
Okay, sir.
Good present side. Got to know process capability.
Yes, sir.
So just one quick question.
Please.
This is normal in manufacturing processes, but when
Yeah.
we have you know uh, research and development or new product development,
Okay.
uh, is it possible that we have a stable process in that situation?
So stable process in the sense during the course of development, most of the times will be depending on the literatures. Like whatever that we are going to develop, so it is going to be from the literature. And also we'll be not taking multiple batches. Like I don't know exactly about the automobiles and all, but coming to the chemical manufacturing industries, what we'll be doing is during the initial stage, what we'll be selecting is the DOE. Why? Because by avoiding the one factor at a time approach, we'll be taking multiple factors for uh, optimization. And after optimization, we'll be taking certain like I mean 3 to 4 runs to check the process consistency. So once it is done, then what we'll be doing is we'll be transferring the technology to commercial scale. So ideally, if it's a chemical manufacturing industry, we are going to evaluate the process capability after getting minimum 30 number of data points. Why? Because 30 is going to be considered as a statistically significant number. Since we are not going to take those many confirmatory experiments in lab, so it is ideally not possible if it's a case of a chemical manufacturing.
Got it. Got it.
Yeah.
Thank you, Arun. Your
Anurag sir, So I'll stop my screen share. Just waiting for Anurag sir's comments.
Just a minute, sir. Just give me a minute, please.
Sure, sir.
Hello, am I audible?
Yes, sir. You're audible.
Very good, Ajay. I like the presentation, right?
Sir.
So, uh, the details you covered, I think it was nicely explained.
Sir.
Right, just one question, right? Maybe redo for you, right?
Sir.
So, say for example, what do you suggest in terms of the capability of the process, right? So, we have the uh, capability like in Six Sigma, we measure the capability in DPM also,
Yes, sir.
right?
Mm.
We measure it in CPCPK also, right?
Yes, sir.
So many times people get confused,
Okay.
right? That DPM, CPCPK, and you have RTI also, right? Or
Roll
first time
throughput yield.
yield, or
Yes,
first
sir.
pass yield, right? So there are so many 7, 8 parameters.
Yes, sir.
Most of the time, seen people getting confused and trying to calculate CPCPK in all the cases,
Okay, sir.
right? So, what is your perspective on it, right?
So
That
DPMO can also be converted into this indices, sir. Like whatever the sigma level is there. So into that we can convert this DPMO. And like coming to first pass yield, if we want to judge about the pass percentage in a single stage, then we can use this first pass yield, like how many defect-free units that we have manufactured to the first pass yield. And coming to the roll throughput yield, to explain about the pass percentage in a total product, like with multiple stages. In such a case,
Mhm.
you'll be using this RTY. Like for example, let's take stage one, stage two, and stage three. I got a manufacturing process with total 3 stages. And the first pass yield going to be for first step, it is 95%. So it is 0.95, and second it is 0.89, and third it is 0.96. Now the roll throughput yield for the total product is going to be the product here. Just we have to multiply.
Hmm.
So it is going to be 0.88168. So this is going to be the roll throughput yield. So whenever we want to talk about the total product performance, so maybe this
Mhm.
roll throughput yield is going to be the better thing to explain to a customer. Like this is the performance of our process. So depending on this, we can explain. And coming to this DPMO. So DPMO, this is going to be something like, for an example, I got a product one, and in this I got some complete analysis after complete manufacturing of a product.
Hmm.
I have to analyze the complete analysis, and this complete analysis is going to have multiple tests. For an example, I
Mhm.
got description, and then I
Mhm.
got identification,
Mhm.
and then I got a water content, and I got HPLC, like the chromatography studies, and then GC, then XRD. So like this many tests I got. So now what we can say is this is the first opportunity, second opportunity, third, fourth, fifth, sixth. So total I got 6 opportunities in this particular product to fail. So I have to see the compliance.
Hmm.
So
Okay.
as
Hmm.
so depending on this, we can say and we can calculate the DPMO. But
Hmm.
whenever we are going to evaluate the process capability, like if I want to say about a product, maybe we can say this DPMO can be used. But if I want to take that whole data of a particular attribute, whether it can be yield or it can be quality, so these indices are going to be very much important. Like we can use this DPMO also, but it all depends on how we are going to represent the data to a customer. That will help us to gain the market. Like if I'm going to show this DPMO, it can be something
Mhm.
confusing. But
Mhm.
whereas if I'm going to show these indices for this n number
Mhm.
of batches, so
Mhm.
I can give some brief explanation at one point. Like this is
Oh,
my view, sir.
no, no, perfect. Very good. Very good. Very good.
Yes,
Liked it. Thank you very much.
thanks a lot, sir.
Thank you very much.
Sorry, sir. Actually, my screen I haven't shared you while typing all these first parcels and all. Just a minute.
That's fine.
Uh, yeah, without screen share, I have typed all those things. Yeah,
No worries. That is completely fine. Yeah.
yeah. Okay, sir.
Very good. Yes.
Thanks, sir.
Friends, any other questions? Questions for Ajay, please.
No, sir. So,
Perfect. Then good. Then we can